Hello and welcome to another free code session. My name is Jason Bach, and now that I have tests around this conversion class, the thing I wanted to play with is to say, could we have a public enum conversion flags where we say exists is identity and is implicit. Okay? But we want to say flags on it. Is it flags? Is that the one? Enumeration can be treated, but yeah, set of flags. Okay, that's what we wanted. So we want to do this because instead of the way I'm doing it right now is I just want to have a conversion flags here, okay? So that gets rid of that. And now what I can say is flags has flag conversion flags exists. Flags has flag conversion flags is identity. Flags as flag conversion flags is implicit. And Bob's your uncle. Alice is your aunt. Now, what we can do here is we can say conversion flags exists or conversion flags. That's it. That's all we need to do. And in this one we say conversion flag exists or conversion flags is identity, or conversion flags is implicit. Now in this one I can say conversion flags exists or conversion flags is implicit. Get rid of all that. And the last one is the none. So if you don't pass one in, can I just say conversion flags none? Okay, here's the test. Do these pass? One failed. Okay, what failed? Verify implicit conversion. Is identity expected false but was true? Implicit wait a minute. Getting confused here. Implicit conversion is identity. It's supposed to be false, but it was true. So is identity. And this was the okay. I gotta pin this for a second because I'm getting confused as to what it was. Implicit conversion. So we're testing the implicit one. Okay. And did I use identity? Because identity is false. Okay. Implicit before was saying it exists, and its implicit is true. Now we're saying an implicit is exists, and it's implicit. And so to set exists identity and is implicit. Identity. I'm missing this. His identity would have been false before. So I see where the test is correct. We expected a false. His identity should have been false. So I'm looking at the right thing. Did that just not work before and I didn't know it? Maybe when I go back and watch the recording, I would have actually failed. Of course, if I actually had a build running in either ADO or pipelines or whatever, it would have failed by this point. I would have seen it already. So, but yes, an implicit conversion means, by what I saw before here, that exists is true, identity is false, implicit is true. And then this explicit, I'm like reading these over and over again going, am I getting this right? This is going to be a little tricky to debug, but I'm going to have to try. So if I say conversion here, on the implicit one, can you put a breakpoint there? Yeah, I don't see how his identity could even work. It's just a getter. And it works for all the other ones. Like identity tests. The identity test, his identity is true. That's the only one where it is true. Because it's literally the only one. Oh, wait, that's 2. That's interesting that it gives you none is that, 1 is that, 2 is that. Oh, crap. I'm being stupid and I'm not. I don't have these as flags correctly? Oh, jeez. Alright, hold on. Because I'm feeling very stupid now. C#, flag, enum. This is where I cut the video with pausing, because I used to, when I would record, I wouldn't do any editing, and then at some point I started cutting out the big pauses, because I'm like, who wants to just sit there and watch me just stare at something for like 20 seconds? That is boring. So make the enum values the powers of 2. If you omit the numeric values, start an increment. Yeah. So, yes, you must declare them. Okay, this shows you that I hardly ever do flags attributes. But this would follow because that should be 4. Okay. Shows you that my assumption, and when you assume, what happens? Yes. Now they pass. Alrighty. So now the one thing I do need to look at here, though, is do I really like this? Do I think this reads better? Does it really mean what I think it should mean? Are these like distinct states? I do like this because it does force you. Well, usually if you use an enum, it's because one of the values is a bool or something, and so you want the enum to have a little bit better meaning. I did that, I think, in rocks rock options class. They could have all been booleans, but then you would just saw true, false, true, true, false, true, and it would have been like, how do you read that other than putting in named arguments? You could arguably say that, well, with the named arguments, it helps it read better, but I don't know. Is this a better way to represent it? I'm not sure. Because the only person that can construct them is this. And so they're the only one that care about it. Yeah, I'm sitting here debating this in my head much longer than I really need to. Because, it's one of those small things. Does it make sense to do this? All right, I think I'm going to keep it this way for now. And I have to debate if I want to keep that internal. I don't know. Still don't know if I like that all being internal, but in any event, once these all pass, oh, you know what I should do? I have the code over here. Is I'm going to look at what he has right now. That's a good point before I finally commit this. That was a good thought, Jason. Good thought. Is this going to expand in some way that I'm not anticipating? And I'm really going to screw myself badly. Nope. Nope, not really. He does a couple changes. He has void and any supported, but the way he does it doesn't change. So, yeah. I'm going to go with this for now. Maybe stupid, but hey. I can be convinced to change. And if I really think it's better to do it this way, I mean, I will admit that if you have a constructor that just takes Boolean arguments, you can make it read better if you include the name of the argument. But then that becomes kind of verbose, though some people would argue that the way I code is a little bit verbose. I like this everywhere. I don't like type names though. I like to use var. So, is that you're now forcing somebody to include the name just so it's readable. Whereas if you use an enumeration, but of course then you have to have the ceremony of having an enumeration there. So yeah, this is where you can discuss these things back and forth. But it is what it is right now, and we're going to move on. So what I'm actually going to do right now is try to figure out this bug. Okay. For some reason, when I run this, a concatenation, and I'm getting a Stack Overflow. That's cute. Before it would just spin. Which is great, because Stack Overflows are awesome because you have no clue. None where it happened. I can't even begin to imagine where this is going to fail. If I go up to here, nope, it's all a REPL. If I say run, we're going to evaluate. Okay, so let's do this. Yeah, add a command run. I already have a command run. Go away. So I don't need that. Let's put a breakpoint here, and let's see where it actually decides to cack. So the syntax tree parse. At least I see where it dies. Okay. Yeah, you're spinning off into the weeds here, huh? So you get into a parse call expression parse arguments, parse primary expression, parse call expression. You just don't get out of it. Okay, try it again. So it knows that there's a call expression, okay? Okay, we know the evaluator is fine. So we do a line expression statement. Okay, so if I do the line expression statement, what I should see is if I peeked and saw that the kind was an identifier token, which it is because it's a print, is we're going to do parse call expression. Okay, so that's right. The line statement should have got the line number as a 1. Okay, so this is all good. We get parse compilation unit, which says parse all the line statements. Now we're on our first line, and we need to parse all of its line expression statements. We're going to find a call expression statement. Okay, so the identifier here is an identifier token with the name print. Good. Open parentheses token is also good. Now we get into parse arguments. Okay, so while the current kind is not the close parentheses token, and the current kind is not a syntax kind end of file token, because the current is a string token. Hello. Okay. So say parse primary expression. This is a string token. String tokens are parsed as string literal tokens, which we say a literal expression syntax for that. So we come out of that, and we're back into parse arguments. The expression is a string token of hello, right? Yes, good. We add that to our nodes and separators. If the current kind is not, nope, it's a plus token. Uh-huh. Yeah, that's the problem. Is that it's assuming that we don't actually do a concatenation within the argument that we're passing in. I wonder if he ever did that in his code and he never caught it, or I just missed a step here. So this is in the parser, syntax, parser. So parse members, parse function declaration, it's a declaration. Does he have parse arguments? Yes, he does. Okay, so okay, so he has it slightly different in that he says parse next argument. He parses an expression. And his stuff is a little not wrong, just different. Oops. There. Parse assignment expression. Well, shoot, I don't know if I'm going to be able to fix this tonight. I know the problem is in that the way he does his this whole parse primary expression and parse expression, I don't really get like what the difference is. So okay, so what he does is he says parse expression. He doesn't do parse primary expression. If I did parse expression, I don't even have that, do I? I took that out. Yeah, because I don't have that expression. parses an assignment expression. And I don't have an assignment expression because there is no such concept to me as a binary expression. We do allow in string and string. You should be able to add those together. Right? I believe you can. Addition, if it's an integer, yeah, we do just string concatenation that way. So if I come back here, and if I go to parse call expression, parse arguments, let's just try this. If I say, instead of that, I say parse binary expression. What happens? Let's do let's do the anticipated one, the anticipated ones. Okay. Did I say run? I thought I said run. So 1 print hello. Run. Hello. Okay. If I say 1 print of a string of a random of 4, and I say run, that gives me a number. Okay. If I say 1 of print of hello plus world, I say run, Bob's your uncle. That was my problem. I wasn't handling the argument, which is an assignment to a parameter, which is it is a variable if I think about it that way. And the way that he assigns the expression is, it arguably is always going to not be an identifier as an equals token. So it's always going to be a binary expression for my case because there are no variables. So that actually works. Okay. Did I say run all tests here? I don't think I did. Okay, good. For a second I'm like, oh, is it like spinning into infinity and not giving me an answer? But that's awesome. All right, because now that means bye-bye. And these, I can actually test. This might be a problem with the engine. This might have nothing to do with the compiler. So I'm going to test that later. This is actually probably a good place to stop because I'm near the end. Let's just do a real quick check again of all the to-dos. Can this be converted to a switch expression? I think it can. So if I say return conversion type switch, and now I say here type symbol boolean convert to boolean value. That's not something you can switch on, huh? Constant value is expected. Okay, well, I guess you can't. So, yeah. All right, well, that's fine. That's all right. Takes care of that one. All right, so a couple more minutes. This is an easy one. I'll stop with this one. This is an easy one. Okay, so we're going to say introduce constant for all occurrences of Boolean. Boolean name. There. Well, we'll figure that out in a second. Okay. Introduce constant for all occurrences. Error name. Introduce constant. Integer name. final one is void name. There we go. Now we want to say here type symbol, because I like this, even though it tells me you don't need to do that. I want to do that. There. Now I'm going to do the same thing here, because I like it, and it can't tell me any different. And there we go. All right, that gets rid of that. That was just a little thing that was bothering me, because, you know. Can I do one more? Move var declaration, and then possibly switch to pattern matching. I don't get the var declaration. That's a little weird. But if I say here return this current kind switch, I think I tried to use the refactoring, and it basically puts in all the values for the kind, which is not what I want. I'm surprised it does that, because it's like, hey, I got a default here. You know, why do you do that? So if I say here syntax kind, open parentheses token, this parse parenthesized expression. Anything else would be a this.parse call expression. Current is not null here. Use expression body for members. Yes, so bite me. It's weird that I have identifier token and parse call expression there as the same thing. I mean, it just goes away because, yeah. Syntax kind, true keyword, or you can't really do this, really. Kind. I don't think it's going to let me do this. This.parse boolean literal expression. Yep. Excuse me. There's no or. Use expression body for methods. Okay, fine. So true keyword is that. False keyword, the same thing. Number token does parse number token, number literal expression. String token does parse string literal expression. Otherwise, everything does a parse call expression. Do that. Do that. Do that. And we're good. Let's make sure. One, print hello. Run hello. I'm good with that, and I'm going to stop there. Okay. There is one I want to show you here, though, that I'm going to do at some point, which is this one. I might do this in my next episode, or I will just be writing more tests. I don't know. But the one I want to just mention here real quick is the toString. The way this is done is it's calling write to. And what write to does is calls print, and print basically prints out the tree that you're seeing. Well, when you're in a debugger, what you see is the value is the toString, and it gets this like really elongated tree, and that's not what I want in a debugger. I don't want to see that. And arguably, toString that's too much. I'm actually curious. I'm going to do one more check here. I just can't stop myself, can I? No, I can't. I just got to keep going. Syntax node. Does he keep this? If I go to toString here. Yeah, he still does it that way. So one thought I had is keep it that way for a toString, but then it's because he never uses. I mean, if I actually go here to toString, no, I don't want not find all references to toString. I want to find who actually calls toString on a syntax node. That's what I really want. I don't want toString on all this stuff. That doesn't make any sense. Let's see. Here, override on syntax node. No reference is found. So nobody calls it anyway. So the thing here that I have to remember is note that no one calls toString on this anyway. So there's a thing that if you have a toString on your object, but you want a different representation in the debugger, you can use a debugger diagnostic. I think that's the name of the attribute. That's an attribute you can put right on the class. And what that will do is it will say when it finds an instance of that class, it will use that to show you information in the locals window, for example, which may be more helpful in a debugger scenario. So that's the thing I was thinking of. And I'm kind of looking at this toString going, toStrings should not be big, in my opinion. They should be as concise as a debugging diagnostic. So in any event, I'm done with this episode. So thank you all for watching. Leave comments and questions below. See you in the next episode.